Okay, thank you. Next question. How are you currently integrating the ERP system with the PLM? All righty, thank you. Last question here, and then we'll hand it over to Satish. Are you planning to manage manufacturing BOMs and process plans within Windchill? Alrighty, thank you everyone for answering our questions. I'm going to hand it over to Satish here and let him get started with the rest of the presentation. Alright, Satish, you should have the ball.
Yeah.
Okay. If you can put it in presentation mode, we can see your screen now. All right, that's good. Thanks, Satish. Go ahead.
Yeah, thank you, Matt. So, good morning and good afternoon, everybody. So today we'll, as Matt said, today we'll look into the past like engineering and manufacturing BOM integrated with the ERP. So first we'll start with the agenda for the today webcast, and initially we'll start with the basic understanding of what E-BOM and M-BOM. And then we'll see how these E-BOM and M-BOMs are managed in the Windchill. And the next we see the associative E-BOM and M-BOM transformation. And then we'll see what's the importance of unifying the E-BOM and M-BOM planning to enable the concurrent engineering. And then we'll see how these E-BOM and M-BOMs are published to ERP. And at the last, we'll see one real use case scenario where we have implemented with one of our customers the E-BOM-mBOM published to ERP. So first we'll see what is engineering bill of material. So as you all know, this E-BOM, that's engineering bill of material, is the type of bill of material reflecting the product as designed by engineering, that is as designed. And as you know, like E-BOM is the list of sub-assemblies where the product is designed by the engineering department. And E-BOM is often organized by the CAD applications like Creo, CATIA. And this is how we see how the E-BOM looks like wheel assembly and the parts which are within that assembly. And then we'll see what is manufacturing BOM. So basically manufacturing BOM contains all the parts and assemblies which are required to build the complete part and shippable product. And M-BOM is basically focused on the parts which are needed to and utilized to build that product. And then the BOM is basically include the information about how the part is related to each other while the assembly is getting manufactured. So we saw what is E-BOM and M-BOM, and now we'll see how the E-BOM is created in the Windchill. So what are the options PTC has enabled in the Windchill to create this E-BOM? The first option to create the E-BOM in the Windchill is by using the create the product structure by structure browser, and then the model driven product structure wherein the 3D CAD applications can be used to create the E-BOM, and then we'll see the options how the E-BOM can be created by using the spreadsheet, importing the spreadsheet into the Windchill, and at the last we will see how the BOM can be used by save as, wherein like if the engineer wants to reuse the existing BOM. The first one here is create in the product structure browser. So as you know, in the Windchill, so user can create the BOM from the product structure, and first he creates the end item which describes the product, and then with the help of option in the Windchill, he can create the BOM structure by inserting the existing, and the second in the insert in the existing, wherein like user can search the existing part within the Windchill, and then he can add into the product structure or the BOM. And the second option he can use is like he can insert the new one. I mean, like if the part is been designed the first time, so he can use the new insert new one and then create the product structure and create the engineering BOM. And once he used all the options which are available in the Windchill to create the E-BOM, this is how the engineering BOM looks in the Windchill. And the second is model driven product structure. So what that means is like if you have the CAD applications like Creo and CATIA, from there design engineer creates the CAD assembly, and then with the help of CAD, so he will directly check in the model which is designed in the CAD application with some options in the Windchill. By selecting those options, user can directly check in the CAD application in the Windchill, wherein it creates the engineering BOM in the Windchill. And the third one is like import from the spreadsheet. So user can also create the engineering BOM in the Windchill, even though he doesn't know how to use in the browser and the CAD application. So PTC has provided the format. It has the defined format wherein like user can give the inputs like the name, number, under which product and the folder it has to reside after it is been importing from the spreadsheet. And then we have the option in import from the spreadsheet in the Windchill, wherein user can browse the spreadsheet, Excel spreadsheet, and then he can create the engineering BOM in the Windchill. And at the last, so if the design, I mean, in the industry, it doesn't mean all the product which are manufactured are from the scratch, from the start. So sometimes some assemblies can be reused from the existing. Maybe like 60 to 70% are same as the existing BOM product, and then maybe 30% are to be created the new. That time, what user can do is he can select the similar assembly in the Windchill and say save as. So he has the option to select the new name and the number. Then he can create the new engineering BOM by using the use of save as assembly, right? So we saw the options to create the engineering BOM. So now we'll see how these BOMs are created in the Windchill. Right, as I said first, from the browser, so you have the assembly called wheel assembly, and already I have added one part. So if you want to create the engineering BOM in the Windchill, so as I said, user can use the insert existing option, and then if he has as I said, like if he has any object which are created new, so he can use the new, he can insert the new object into the engineering BOM, then he can create the product structure. and the second option, import from the spreadsheet. So I have the option from import from the spreadsheet. So wherein I can browse to the Excel sheet where I had defined the how my engineering BOM to be. Then we have the option wherein like we can validate the spreadsheet. What that means is like it has some format which Windchill understand. If that format doesn't match, so you can validate the spreadsheet. Maybe there is some issue in the spreadsheet. So we have the option wherein like the Windchill will validate, and then once the validation is complete, so validate success, then I can say import. So by doing this option, the BOM is directly created into the Windchill. Right, if I see here, the BOM is created. So the next option is like, as I said, from the CAD application. So user creates the CAD design in the application, and once he done with all the design as per the specification, so user can go here and say custom check-in, and by selecting the options for creating the variables, like there are three options: models and variables, models and variable. So the Windchill, in the check-in, Windchill give of the option to create the BOM in the folder which the user can define. So I say here is like I will select one the folder structure as a BOM here, and if I go next and say auto associate the part to the CAD, what it does is like if the part is already exist into the Windchill with the same number, it will associate with the existing parts. If the parts are not available as a CAD structure, it will create the new part for the particular CAD application, then create the engineering BOM in the Windchill. So the next one, as I said, like see, like I have this BOM, engineering BOM. What engineer feels is like, yes, most of the part, like 60% of this BOM is similar to the BOM which I am planning to create. So what user can do is go here and select the option or save as, and he can select the collector here, like I want a dependency all, and he can collect all the drawings parts related to this. And then you have the option here, if the auto numbering is on, it automatically generates, but in the name, so still you can have the option to create the new name as per the request, and you have the option here like set the name, where I can say here like test, right? So you can see here automatically all the name of this particular BOM is renamed as per my given input. So if I say OK, and even user can specify the folder where this BOM has to be reside in the Windchill. If I say OK, the BOM is created in the Windchill. So if you see here, the test assembly to test is created, and the structure is created in the Windchill. So these are the ways, the options in the Windchill to create the engineering BOM. So now we'll see how this eBOM-mBOM transformation, that is associative eBOM and mBOM transformation. So associative eBOM-mBOM transformation is like define the manufacturing process during the product design phase. Like we'll see what is the PTC application which supports this associative design. as you all know that in the manufacturing industries, the basic challenge of associative E-BOM M-BOM creation is, so engineer doesn't understand the manufacturing process, what the manufacturing engineer is thinking of, how the part is manufactured, and sometimes manufacturing doesn't understand the engineering design, how the part is been designed. And we'll see in detail what are the challenges for associative E-BOM, M-BOM. The first thing, as we discussed, E-BOM and M-BOM never be the same. They are different. Different from their perspective. Design BOM is as per the design perspective, and the manufacturing is the manufacturing perspective. And the biggest challenge here in the E-BOM M-BOM transformation is like shorten the development schedule. So manufacturing engineer cannot wait until the engineering design is completed. And the last is ensuring the conformity, like any mistake, any issue in the M-BOM can end up in the production scrap. Even the production lot can be scrapped, and it cause for the rework and delay. The main thing is like, if you are not ensuring the conformity, it may delay in the customer delivery, right? And we'll see what are the capabilities of associative E-BOM M-BOM transformation by using the PTC solution, that is MPMLink, right? The first capability is ability to create the M-BOM from the engineering 3D mockups. So while creating the manufacturing BOM, so manufacturing engineer doesn't need to create the 3D visualization for how the part to be manufactured. He can reuse what the design engineer is already created in the engineering BOM. And then second is the main capability is he can create the manufacturing equivalent part link. So we'll see what is that equivalent part in the next coming slides. And the next is able to manage the bi-directional associative between the E-BOM and M-BOM. What the mean is like engineer can get the feedback from the manufacturing engineer when he is creating the M-BOM, and manufacturing engineer get the feedback. So there will be bi-directional associative between E-BOM and M-BOM parts. And the next is ability to analyze the resolve the BOM disturbance. So in between, if there any discrepancy in both the BOMs, so both the engineering and the manufacturing can communicate each other and can analyze and resolve any BOM discrepancy. And the complete traceability. So while you are transferring the E-BOM to M-BOM, the basic strength of this associative E-BOM and transport process and the model is like you can have the complete traceability between both the BOMs, E-BOM and the M-BOM. And the last is application of change, and you can have the single change management process for both the changes if anything is being called while creating the engineering and the manufacturing BOM. So what that mean is like you can, the engineer and the manufacturing can identify the required design changes earlier in the design phase before he is released into the manufacturing. These are the capabilities in the associative E-BOM M-BOM transformation. So we'll see. So the PTC solution which is used to create the engineering and convert the engineering BOM into the manufacturing BOM. So the Windchill PDM-Link is the solution which is add-on to the product to the Windchill PDM-Link. So what that mean is like here in the engineering BOM create the engineering bill of material, and as we earlier discussed, engineering BOM, a manufacturing BOM will not be same as the engineering BOM. So once the engineering BOM is created, then manufacturing engineer will define his manufacturing strategy, like how the part should be manufactured. So here, if you see this example wheel assembly, so manufacturing engineer will define the strategy like how this part to be manufactured as per his capability and the manufacturing process. So he said like engineering can say it's the wheel assembly, but manufacturing can have the different strategy how this part can be manufactured. And then at the last, by defining the manufacturing strategy, the manufacturing engineer will create the M-BOM as per his defined manufacturing strategy. So we'll see why we need the PTC Windchill MPMLink for M-BOM creation. So as you all know, like if you are aware of E-BOM creation process in the Windchill, so we have the option in the Windchill called the view mechanism, right? So we can still use the view mechanism by creating the M-BOM, but it has a lot of limitations. So the first one is view cannot ensure the traceability between E-BOM and M-BOM. And if you see this picture here, E-BOM, M-BOM, so the E-BOM is different from the M-BOM with the name and number. So if we create the M-BOM with using the view mechanism, so you cannot have the traceability if the part number is different from the engineering BOM. So you don't understand like which is my engineering BOM which defines the manufacturing part which I'm manufacturing in this assembly. And as I said, is cannot anymore ensure the traceability, and while doing the change from the engineering, so you don't have the traceability, engineer cannot define which is my affected manufacturing parts which will affect by doing this engineering change, right? So for this purpose, to overcome the view mechanism, so PTC has introduced the MPMLink with the equivalent link into that, which creates the link between engineering part and the manufacturing part. So if you see here, what you mean by equivalent link is basically the equivalent link is the link between the upstream, that is engineering BOM part iteration, and its equivalent downstream, that is manufacturing part iteration. So this is the basic concept behind using the MPMLink for converting E-BOM to M-BOM. And you'll see what is the purpose of having this equivalent link while creating E-BOM, M-BOM. So you see here, this is the M-BOM, that is brake system, and this is E-BOM, and this is the M-BOM. The manufacturing engineer defines how this brake system has to be manufactured. So if you see, so you don't have any link, which is if you see the M-BOM, you don't find any brake system assembly in the M-BOM. So where is the brake system assembly in the M-BOM, right? So we cannot define if you don't have the traceability between both E-BOM and the M-BOM. But with the help of this equivalent link in the MPMLink, user can see, he can trace which is my upstream engineering part which reflects which associates between E-BOM and my M-BOM part, right? So now if the engineering BOM says the brake assembly, but in the manufacturing BOM it says he has split that brake system into two assemblies, that is rear and the front assembly. And next is like the purpose here, if you see here the same thing, like engineering BOM has the different nomenclature in the manufacturing. So we cannot say what is what, the same, like which part reflects the engineering part of that upstream part. So if we have this equivalent link, though both, the manufacturing engineer, the user can have the traceability between engineering part and the manufacturing part. And the next purpose is like sometime the engineering, these parts can be manufactured in multiple plants. So maybe with some constraint with my existing supplier, maybe my in-house manufacturing process capabilities. So if this part is manufactured in the different plant, So manufacturing engineer still can create the plant specific BOM, but still with the help of this equivalent link, he can trace which is my part in the different plant context with reference to the engineering part. So the wheel design part has been equivalent part in the wheel manufacture in the context of plant 1. But if you see in the plant 2, still the manufacturing doesn't call for the wheel assembly, but still it has the link, that association link between wheel and the manufacturing part, that is for part 450 manufacturing part. And even while transferring the engineering BOM to manufacturing BOM by using the MPMLink, so we have some status indicators, right? So the example which I saw was very small bill of materials, which has only 10 to 15. So say for example, if we have the BOM, maybe by any automotive like car and truck brake assembly, so you may have the parts in the engineering BOM around 100 and 200 parts. So that time, user cannot have the traceability like what is my part still to be converted as a manufacturing part. So you don't have any. If the BOM is bigger size, so you don't know like which part is. But with some capability, that is status indicator, still you can understand which is my part which is still not been transferred to the manufacturing part. So the symbol here with the triangle yellow, it says no equivalent exists. What that means is still this part is not transferred to the manufacturing. And if it is with the green symbol, then it shows yes, the part is been converted. And with this symbol, equivalent links exist, but not on the latest iteration. What that means is like that is the upstream and the downstream part is been updated. Both are not in linked to the latest iteration. So these are the way wherein we can transfer the BOM transfer E-BOM to M-BOM. That's a new part wherein like numbering must be different. If the engineering E-BOM and the numbering M-BOM numbering is different, we can use the new part and the new branch, and the same as where E-BOM and the M-BOM parts are the same, and some phantom, that is the stockable assemblies, non-stockable assemblies. These parts exist in the BOMs, but they are not physically the part. It represents in the BOM for the structure purpose, and then manufacturing part only. These are only at the manufacturing BOM. That's like the consumable parts without corresponding to E-BOM. And then we can create by using the alternative BOM, that is plant specific BOM. So this is how it looks when it comes to the E-BOM, M-BOM transformation. Like if you see in the left side, it talks about the E-BOM structure, and the right side, it is the manufacturing BOM. So we'll see in the demo the detail, the process of how the E-BOM, M-BOM is transferred, right? Right. So at all this time, we were talking about the MPM key capability to enable the concurrent design, associative, E-BOM, M-BOM transformation. So we'll now look into the business value point of view, how the customer is benefited by using the MPMLink key capability of concurrent design, both the E-BOM and the M-BOM. Like if you see in the slide, like this is the older traditional method of manufacturing process, not beginning until the engineering design is released, right? So first he starts with the concept design and do the detailed system design. Once the system design is done, so then he will do the detailed design by creating the drawings. Then it is released to the manufacturing process. After the good amount of time the design engineer done all the detailed design, then the manufacturing engineer will start doing the manufacturing process, creating the M-BOM. Then the production ramp up, then full scale production. So here the limitation is manufacturing engineer doesn't have the opportunity to influence the design and reduce the cost. So you don't have any time, because already the design has been frozen, then the drawings are released, and then the manufacturing will start the manufacturing. So at this point, what happens is like if you see this graph, number of changes and products, the product development life cycle. So there will be a lot of changes after the design is been released. This is how the typical the MPM process. So if you consider the concurrent product design, that is a simultaneous designing of both the E-BOM and M-BOM. So what it means is like if you can overlap the engineering design process and the manufacturing process. So how the advantage is like the engineer can identify the required design changes earlier in the design process with timely feedback from the manufacturing engineer. So there will be a lot of reduction the cycle time, and this is the concurrent product design process wherein the changes can happen in the design before the parts are released to the manufacturing. So it reduces the cost of the changes and reduce the manufacturing cost. The biggest advantage is it reduces the time to market. That is the biggest advantage by doing this concurrent product design. So you all know that PTC has released the Windchill 11. So for eBOM-mBOM transformation, there are a lot of changes when it comes to the Windchill 11. So there are in the basic advantage. I mean, the biggest changes in the Windchill 11 is like PTC has introduced the new HTML UI for the BOM transformation when you compare to the old Java applet, and then the lot of highly visual experience. I mean, the user experience like. Now the attribute of upstream and the downstream can be seen the side by side, and the documentation tab is here, and the user tab, and the main thing is the visualization. So 3D was the another window in the applet, the Java applet, but now in the Windchill 11, both the upstream and the downstream visualization can be visualized in the single window. So, and one more biggest advantage is if you can see the gray parts here. So, whatever by 3D mockup, like user can identify the gray 3D model says that the BOM is transferred, that this part is already been transferred to the manufacturing BOM. And as I said, like 3D integration is the biggest changes what the PTC has introduced in the Windchill 11. And now we will see the demo of how this BOM can be transferred in engineering, the engineering to manufacturing BOM. So this is how it looks when it comes to MPM. So this is my engineering BOM. So here user can go from action, open, and open in the product. I mean the manufacturing product structure explorer MPSC. So once I click this, so it will open in the manufacturing product structure explorer. So I was discussing about the status indicator here. So if you look at here, the equivalent part exists at the point of latest iteration, but here equivalent part doesn't. What that means is, if you see his test connecting rod is not been seen in the manufacturing BOM here. So it means that still this part is yet to transport to the M-BOM, and this indicates that there is some changes between in the upstream and the downstream. It's not pointing towards the latest iteration. So to transfer the E-BOM to M-BOM, so this is my left hand side, my engineering BOM. So if I select here my right hand side, so here you have the option to transfer the BOM, assemble as is, and assemble as a new branch, and altogether the new part here. So if I select here this, if I say like I just want to make this as is, right? So if I select here, it will ask for the downstream view and the BOM type and alternate BOM. If I say yes, so automatically this BOM will transfer. The status indicator will immediately change to the equivalent part exist and point to the latest iteration. This is what I was talking about, the equivalent link, the advantage, right? So if I click here and say update the equivalent part, it will ask, all right. See, if I refresh this part, immediately the symbol has been changed. It says equivalent part exists to the point to the latest iteration, right? And I was talking to you about the Windchill 11, the HTML UI. Here, this is how it looks in the Windchill 11. Both the engineering and the manufacturing BOM are side by side. So as I was talking, the attributes, the basic changes, the main change attribute of upstream and the downstream are side by side. So you have the visualization tab here, so user can see the 3D visualization of the engineering BOM and the manufacturing BOM. So there is a process plan directly here in this side by side. So there are basically the major changes in the layout and some functionality wise in the Windchill 11. So this is what I'm done with the engineering BOM and the manufacturing BOM transformation. So now I will hand over this slide to Lakshmi to take you through engineering and the manufacturing BOM published to ERP.
Thanks, Satish. I will switch the presenter here to Lakshmi. And
can you see my screen?
Yeah.
Yes, we can see your screen.
Okay. Thank you. This is Lakshmi. Good morning and good afternoon. I'm going to explain about now the bill of material in Windchill are ready to go to distribute among manufacturing plants. So I'm going to discuss about what options are available, what components are available within the Windchill for integration purpose, and a real-time scenario what we have provided a solution to one of our customers. It's a high-level architecture. What are the components for integration purpose with ERP available within Windchill? Windchill PDM-Link, you can see at the leftmost what components available with the Windchill PDM-Link solution, that is ESA services, and the other one is ERP connector. So ESA services provide the bidirectional integration where it can take the information from Windchill in terms of attributes, and it can provide the same information at the ERP side, and at the same time it can retrieve the information from ERP by using various customization and adapters which are available within Windchill ESA as part of Windchill ESA services. That is ESA business logic, ERP specific adapters, integration suites, and some of the adapters which are available to like TIPCO. So we can do extensive customization to provide the solution to the customer as per their requirement for bidirectional. In case of ERP connector, it's a unidirectional integration where it will provide the information from Windchill in terms of FTP server, where it will send the data from the server to the targeted system using FTP services, and email also available as part of option to distribute the data. And one more option is the file. So the file option, it provides the data in terms of XML at a configured location in network drive. Once it is published, then the data which is needs to integrate with the ERP. In case of ERP connector, they supposed to either manually or a custom process. We have to we have to process the data, and then we have to integrate with the ERP. This is how the high-level architecture is available with Windchill. And Windchill integration options. What are the options available to integrate with Windchill? When integrating with Windchill, for the purpose of connecting with ERP system, there are three options. That is Windchill ESA, that is out of the box SAP and Oracle supported by PTC, and ERP connector is a unidirectional module. It's out of the box. It is available with Windchill. So we have to process whatever it is providing in terms of XML format. And the third one is ESA Open API to customize our requirements to make use of either one or second option, ERP connector. These are the listed objects of Windchill which can support during integration with distribution target. This we are going to discuss in later. So the parts, Windchill parts can be supported, documents, the bill of materials, engineering change notices, and the objects of process plans like operation sequences, process materials, and skills and tools. These are the supporting objects during integration. Now we'll see what is distribution target. The distribution target is the destination for the data sent from Windchill MPMLink. This is we can call that as an instance we need to configure to send the data from Windchill to a specific plant. So we can configure this one. We have to create as many plants. We have to create the distribution targets, and also we can configure. Let us say like we wanted XML file to be generate in a specific format. So the style sheets and different types of attributes and some of the filters and Windchill objects. We can define everything. We can define at distribution targets. So we have to create for each specific plant distribution targets, and represents another ERP system, that is enterprise system, such as ERP. It's an entity within the system, such as manufacturing plant. And a distribution target table as shown, you can see here for a given Windchill object, as I mentioned previous slide, there is a part, Windchill parts. So for each part, you can see how many plants are available. So whether that part is published successfully to the ERP system or not. So we can have this under distribution target table within the Windchill. There are three ways to publish the data. So once our bill of material is ready to distribute among different manufacturing plants, there should be some triggering point to distribute, provide the information for integration with ERP. As one is the send to distribution target. It's a link. This action is available in user interface, either in context menu or in actions menu in Windchill. You can manually send the part to the ERP for integration purpose. And the second one is release to manufacturing workflow. That is automatically the process will trigger once any of the listed above or the Windchill objects, supporting objects for integration reach to a specific lifecycle state. That is, we can configure either release or production. So whatever the state defined for the manufacturing. Once the object is reached to a specific lifecycle state, the integration process will start automatically in background. Mostly the releasing the workflows, the promotion request, promotion process. At the end of promotion process, the data will publish to the ERP, and upon completion of engineering change notice. And also, in some cases, we wanted to trigger the publishing to ERP programmatically. So we can use the API. We can achieve the same using customization. You can see here, I'm just giving the idea of like in Windchill how it is the publishing. we can publish. You can see the left top, the bill of material is ready. So we are going to publish this one using the send to distribution target option. You can either in actions or in context menu, you can see the send to distribution target action. So once it is, once you click this, then you will get the one window where the list of objects of bill of material, whether it is a create, you can see here the leftmost the actions, whether it is, if it is a create, if it is a new to the ERP, the part number, then it will show it as a create. If it is change, it is the second time when it is after revising, after making some modifications, if it is going in the second time or later, then it will come as like a change, or in some cases delete. These are the actions are available in this list, and then you can go for the finish. Once you go for the send, then it will, in case of any modules, any components, either connector or ESA services, it will provide the data in a required format at the destination location. And you can see here, in case of a MPMLink, if you have, then you can see the ERP tab, where what information it is published to the ERP. You can see the list of attributes listed for distribution. And here at ERP side, we can edit the information. Let us say like currency or inventory. So we are just editing at ERP side, and we are retrieving from Windchill. So that I would like to show later slide how it is. So you can see here the currency and the inventory. Once we go for the retrieve, whatever modifications done at ERP side, that will be updated back in Windchill. So this is how bidirectional can achieve using the ESA services. I'm going to take one of the real-time scenario, the solution what we have provided to one of our customer. So the main objective is they have a current PDM system. They wanted to migrate all their objects into Windchill MPMLink solution, and Windchill MPMLink solution we need to integrate with the existing ERP system. So in this case, the ERP system remains same. It has to work seamlessly without having any issue with even with the new Windchill MPMLink system. So the integration objects, WT parts in Windchill will go as item masters. Item master, once the item master is created in ERP side, then we have to write down to the branch items. That is nothing but different plants, manufacturing plants. In the product structure, it will go as the BOM items in ERP, and the bill of material item, it has to go as item BOMs and the manufacturing BOMs in ERP. And the main thing here is the attributes. So here Windchill IBS, instance-based attributes, what we have defined within the Windchill for parts. So the user-defined attributes, in that user is going to give their inputs, the values for these attributes, and another 40% of attributes are calculated attributes. Those are calculated based on the inputs given by the user-defined attributes. So there are nearly 250 columns are needed to integrate with the ERP system. And another part is the logical attributes. These are the attributes are calculated the value of the attributes using the engineering math provided by the customer. So it has handled by our integration tool. And the constants. There are few attributes which needs to provide a constant values, and the reference plant attributes from the ERP. There are some attributes which they are giving at ERP system, like from planning department So they are providing some values. So in case of changed parts, when we are sending back to the ERP, so in that case we have to refer whatever attributes modified at ERP side. So we have to make sure those values also retained during our change parts when we are integrating with the ERP system. So this is how we need to manage. It's a kind of a total requirement nearly 250,000 objects of bill of materials we have integrated with the ERP, and also it is running with the current ERP system without having an issue. You can see here the high-level architecture of what we have provided. So the integration of PDMLink with the JD Edwards is the ERP system of this customer, and PDMLink ERP connector is they have gone for ERP connector as a component of Windchill, and the output is the file type where it is generating the XML file. So here you can see whatever data available in file. So XML file, we have developed one BW ERP connector. This software tool, what it will read, there are Windows services also available. It will keep on monitoring when XML is created. The moment XML file is created upon publishing from Windchill, then the complete information will write down to the staging database. Because the main purpose of staging database here, since it is not having the bidirectional support in case of ERP connector, here it needs to manage the return values from the ERP in order to proceed for following subsequent processes. So that's what the staging database what we have managed here. And first the tool will write the information to the staging database. Once that is ready, then it will send to the Z table. It's the intermediate database for in ERP. Once everything fine, then it will publish to the master database. So during once the items are ready, item masters are ready, then it will give back some unique numbers and success status also it will provide as a return value. So it has to handle and write back to the staging database. And after that, it has to write the particular part numbers and distribute among the manufacturing plants. That's the second process what they wanted. So this is how it is handled. It's a high-level diagram what we have provided as a solution to the customer. And this is a blueprint from the previous system. They have a wrench pillion, and where the part master is integrated with JD Edwards. In a 1-2 path, you can see item master went to the JD Edwards. Then 3-4, it will write back the unique ID, that is short item ID, back to the part master. And once short item ID is ready, then if it is success, then it will write back as a item branch. That is two branches are there. One is 220, the plant number 220, plant number 240. So it will write back with the available information what it is provided with the plant from JD Edwards. That is a unique number. Item branches will be integrated with JD Edwards. In case of bill of material, for all the components, it will make sure that all components within the bill of material will publish as part masters first, and make sure everything is tagged with the unique number provided by the ERP. And once everything is processed individually, then the bill of material will publish to the JD Edwards as the manufacturing BOM and item BOM. This is the blueprint from the customer, and this is the functional flow diagram of the tool what we have developed for this customer. So yes, using ERP connector, XML will publish at a required location where we configure. So that XML, using that information, we are going to check the part whether it is a change part or a new part. In case of change part, we have to get the unique number provided with the ERP system. we have to carry that unique number unless it will not integrate. And if it is in case of new, then we have to provide the batch number and transaction numbers. So that also we are getting from the latest batch number transaction numbers initially. So once this is new, then we have to read the part attributes. In case of read attributes, we'll have a new part or changed part, and the attributes are whether it's a substitute or alternate parts. And also we have to find out the bill of material, whether it is a changed bill of material components or a new bill of material components, or it is a deleted component. So we have to read all the information, and we have to write the information in terms of item master in a table, and then we have to publish to the Z table, that is the intermediate database. And once that is published, then if it is a success, then it will get back provided the short item ID, that is the unique number, and the successful status also. So once this is done, then we will check whether it is a successful or not. If it is successful, then we'll proceed for writing to the plants. Otherwise, we'll write down the errors, whatever we come across, to the log files. There are two plants. We have to write down the information, whatever we acquired here, and with the unique number provided by the ERP system to the plant, 220 and 240. Once this is done, then it will complete information, the plant information, it will write down to the JD Edward, that's the ERP. So for the part, we have done everything till plants. We have write down all the information we have integrated. Now the time is to process the bill of material. We are going to validate whether it is a success or not. So once all the components of bill of material success, then we'll write down the I-BOM and M-BOM as part of our integration. If it is having any component is having any issue, then we'll write down the log. So that we also provided some manual user interface. So in order to handle, if in case of failures or anything, they can handle using the user interface manual approach to integrate with their ERP system. This is how it is integrated, and we have provided the information so that the current ERP system, no matters like ERP, what solution, what is the source solution. So it has to provide the information in a correct way so that it will integrate without having any issues. That's what we managed from Windchill, and also in our integration tool, what we have developed to manage the return values from ERP, and also complete the process without having any failures. Yeah. Thank you. This is what from my side. Thank you.
Thank you, Lakshmi. We will. We know we're going a little bit long here, folks, but you know, we got a couple of questions here that we want to share with you. Sorry. Let's see here. Hey Satish, I'm gonna make you my screen's not showing up, so I'm gonna make you the presenter here real quick, just so we have a screen up.
Okay, it's okay.
But let's go with the questions. First question is, in the demo, the M-BOM is having design parts. How can this go downstream? Aren't we supposed to have only manufacturing versions?
Yeah. So what I understand from the question is like engineering has the upstream and the manufacturing have only one downstream, right?
Correct.
Yeah. So as I said, like when you look into some assembly in my presentation in some slides wherein I explained about yes, one E-BOM can have multiple downstream. The one upstream part can have multiple downstream part, and one downstream part can have multiple upstream parts. Yes, it's one to n to one link between E-BOM and M-BOM.
Okay.
You can have you can have the multiple downstream for one upstream. Yeah.
Yeah. Next question is, when we apply filter configuration on M-BOM assembly, will we not see the design parts?
Yeah. So when you apply the filter in the M-BOM, so you will only see the manufacturing part, not the design parts. So you will only see the design parts wherein you have used the option for use as is.
Okay. If the ERP connector is unidirectional, does the ESI bidirectional?
ESA is bidirectional.
ESI is bidirectional. Okay. Let's see. Bidirectional means does the updates done on ERP will be reflected back to Windchill? Right. That's a yes again, correct?
In case of in our last demo, we have given our own tool which we have converted in ERP integration. So that is actually handled the return values as part of like even in case of ERP connector. But ESA is a bidirectional, and you can have a ERP attributes can retrieve back to the Windchill.
Okay. Why should we integrate Windchill with that of an ERP?
Yes. So why should we integrate is the Windchill with the ERP is basically, so we have all the design parts in the Windchill. So basically it is to make the Windchill as the single source of truth, and then publish all the manufacturing BOM into the ERP. So when it comes to the ERP, so ERP maintains your all the the stocks, and it can the work order. So for this purpose you need the manufacturing BOM, which is created from the engineering BOM. So main thing is the single source of truth will be for all the manufacturing part will be the Windchill where the parts are designed. So to publish the manufacturing BOM from the Windchill to ERP, we need the ERP integration between Windchill to ERP.
Okay. Next question is, how are you going to handle the variant M-BOM, and also what if the user requires a replace functionality for a one-to-one part?
Yes, Windchill also supports the variant BOM and the options and the variant in the manufacturing BOM.
Okay.
Yeah, yes, Windchill has the capability to do that one.
Okay. E-BOM to M-BOM transformation can address variant and effectivity configurations?
Yes, it does support.
Okay. All right. What ERP systems have been successfully integrated? These people currently use Macola, M-A-C-O-L-A.
It can be integrated with any ERP system because we have to get the schema of that ERP system. We have done for various ERP systems. So only thing is we have to study the schema of the current ERP system, and we can support that integration using the open source API that is available with ESI. And also currently the supported the SAP and the Oracle, it is supported by out of the box with PTC for ESI.
Okay. And let's see, one last question is, what is E-BOM?
The item bombs, whatever we are going to integrate, so they have a set of attributes which are different for particular items for this customer. So we can show the different data in item bomb, whatever it is available with the WT part. So where it is not available with the plant information, so we are providing the data what is available within the Windchill in item bomb.
Okay. All right. Great. Thanks, guys. We're going to wrap this up now. Everyone, you'll be getting a copy of the webcast. We'll be emailing that to you tomorrow. Also, you'll be able to find all of our webcasts on our website, www.b-wi.com/webcast. We're also participating in a PTC virtual event all around BOM visualization and Windchill as well. Later on this month, March 21st, we'll send you an invite to join us for that as well. So you can get a little more hands-on information about BOM and change management and component and supplier management along with production planning. So thank you, everyone, for joining us. We appreciate spending your afternoon with us, and look forward to seeing you at the next webcast. Thank you again, and have a great day.
Okay, bye-bye.